Good morning. Myself, Dr. Juluru Sandeep. Today, I am going to give lecture on CFD as a research and design tool. So, the course outcome, summarize the concepts of computational fluid dynamics and its applications in industries as a tool for fluid analysis. So, in continuation to the previous lecture, so we have discussed about the importance of CFD. So, what is the process of CFD? So, why CFD is used in fluid dynamics. So today we are going to discuss about the CFD as a research tool. So CFD is often called as research tool because it plays a fundamental role in discovering and understanding the fluid dynamics phenomena. So as we know, the fluid is having chaotic characteristics when the flow has high speeds or turbulence characteristics. So understanding that flow phenomena is a very difficult task. So with respect to the traditional procedures, we are going to depend upon the experimental ways, or we are going to depend upon the analytical studies to understand this flow phenomena and to give the best design for the requirement. So the basic traditional experimental procedures will have some drawbacks. So because of that, in nowadays, all the research organizations are using the CFD as a research tool. So basically, the experimental facilities are going to be limited, and we have so many reasons why we are going to consider CFD as a research tool. So research is a very big task to analyze the problems which are going to be faced day by day. So that has to be solved, and the research scientists are going to explore on these problems. So with respect to that, in aerospace engineering, we can consider like hypersonic flow phenomena, which is a very complex flow phenomena. So that has to be solved to go for the space explorations. So all the re-entry vehicles or the rockets, they are going to travel in these hypersonic speeds. So there is plenty of research is going on these hypersonic speeds, but with limited experimental facilities, we cannot explore all types of problems. So that we are considering the CFD as a research tool. So in coming to the reasons why we are considering the CFD as a research tool. So we can consider CFD as a portable wind tunnel, CFD as a virtual laboratory where experiments cannot be conducted through the experimental facilities. So to have these hypersonic facilities or the complex flow facilities, we need a very huge equipment. We need very high wind tunnels where it occupies the more space, so that it is going to be very complex, or it is going to be very difficult to do such type of experiments. So the CFD, which is a program software, so which can be loaded in your desktop or in your laptops or in your computers, so that we can solve these complex flow problems. So thus CFD allows the scientists to simulate these flows virtually. So virtually, you can solve these problems by sitting in your house or by sitting at your workplace. You can use the cloud apparatus, and you can solve these flow problems without any type of disturbance to your regular work. So that we are considering the CFD as a research tool in terms of the virtual laboratory for the complex flow problems. So, and also we are going to consider CFD as a research tool because it is going to solve the uncovered fundamental physics. So as we have seen in the process of the CFD, we are going to choose the different turbulence models to solve the flow problems. Okay. So like we have K epsilon, K omega, SA model, and here we are going to see the RAS model, Reynolds average simulation, and LES model, large eddy simulation, and DNS model, direct numerical simulation. So these models has been developed to solve the complex flow problems which are being not solved easily by the analytical methods or easily by the experimental methods. So based upon the complexity of the problem, based upon the eddies that are going to be formed in the problem, so we are going to use the turbulence models and we are going to solve the equations and we are going to solve the problems. You can observe in this diagram the Reynolds average simulation results are going to be given with a normal contours, and in the large eddy simulations you can see the fluctuation of the flow and a small eddy captured. And then in the direct numerical simulation you can see even small eddies or fluctuations are also being captured in this type of model. So researchers are using CFD to study turbulent flows and to study the shock boundary layer interactions and to study the combustion instabilities, so multi-phase flow problems. So all these type of complex flow phenomena can be easily solved by the CFD. So if you want to solve this problem in an experimental way, so you have to create the environment, you have to supply the apparatus or the equipments to capture that flow physics, so which is a very high cost. We have to have the high resolution cameras, and so that the dynamic phenomena or the unsteady phenomena, so capturing is going to be very difficult with the experimental apparatus. Within microseconds it is going to happen. So these phenomena will be very difficult to solve by using the regular procedures. So these simulations generate high resolution data, so that theory or experiment cannot easily provide. So this resolution data is very, very important to analyze the problems and to provide the solution for the problems. Even though you are doing the realistic flow phenomena by using the experimental apparatus, but attaining the data is very difficult. So because the hypersonic speeds, if you can observe, they are traveling at 3000, 4000 meters per second. So where the fluid residence time is in milliseconds or in microseconds. So that data we can easily obtain by using the CFD simulations, and we can analyze the data in the post-processing method, and we can solve the uncovered fundamental physics by using this CFD as a research tool. So similarly, the major task in the research analysis is we are not going with one set of experiments. So we have to solve it the n number of times to get the solution in an optimized way. And also we have to consider all types of scenarios, all types of conditions, all types of situations to understand the behavior of the product, so that it is going to operate efficiently in all types of conditions. So the CFD can test the model what if scenarios. So what if scenarios means if it is the product has been developed for a laminar flow, so then if turbulence flow is going to come across, so how the product is going to behave, so how it is going to give the output. Okay, so these are all considered as a off design conditions. So you have designed some particular component for a Mach 5 or Mach 3. So, but if the component is going to face some Mach 7, Mach 8, so then we have to understand the behavior. That is the off design condition. That is a major important thing in the research analysis. So the CFD can make this hypothesis testing, what if scenarios, and what happens if fuel is injected at different angles in a scramjet combustion. Okay, so the normal injection is going to be done in the scramjet combustor. So, but when you are going to fly during the different maneuvering conditions, the injection of the fuel may change its angle. So, we have to consider all these parameters into the analyzing of the particular component. So, the CFD can do the parametric analysis easily, where we can obtain the solutions with less number of time or with less cost. So that is the advantage of CFD as a research tool in hypothesis testing. So these are the some of the points where we are going to consider the CFD as a research tool. So similarly, one more advantage of using the CFD as a research tool is scalability and generalization. So as said, the CFD is going to create some CAD model, and it is going to test the flow by solving the governing equations, and then it is going to give us the results in terms of the different fluid flow properties, maybe velocity, pressure, temperature, and other parameters. So here the initial prototype is going to be developed. So this prototype is going to be solved for the different conditions. Okay, so then we are going to we cannot make the original model, and we cannot test in the wind tunnel. So the same size we cannot place in the wind tunnel, because the wind tunnel size is very less compared to the aircraft models or the rocket models. So we are going to scale that model. And we are going to we are going to test the model in the wind tunnel by satisfying the similarities. So when you are doing the experiments, we have to satisfy the geometric similarity, we have to satisfy the dynamic similarity, we have to satisfy the kinematic similarity. So then only the results obtained on the scaled model can be replicated with the original models. So that drawback we have in the experimental procedure. So that can be overcome in the CFD. So we can design our models with respect to the original dimensions, and also we can test it. So but we have to have the capability of the computation power. Okay, so when you are going to solve the original models, so you may be getting the number of volumes in millions or in billions or in trillions. So like that, the number of volumes are going to increase as the size of the domain is going to be increased. So when the number of volumes are increasing, then the time taken for the computation is going to increase. So you have to use some parallel processing method. Okay, so we have to use the high power computing facilities, so where you can have the number of processors, so that the total problem will be divided into some blocks. Okay, so that each processor solves the each block, and it is going to give us the results in the less time. So the parallel computing will plays a vital role in the CFD. Okay, so that we are going to have the good solution for the research problem by using the parallel computing. So similarly, we are going to consider CFD as a complementing for the experiments. So in research, as we have discussed in the previous class, the CFD acts as a third pillar of the fluid dynamics. So where it combines the theory and the experimental, and it is going to give us the results in the computers. So where the experiments are too costly and too unsafe. Okay, so when you are going to solve these hypersonic flow problems, the temperatures will reach us up to 3000, 4000 Kelvin. So where the gas cannot be considered as ideal gas, it will be turns into real gases. And so that type of experiments are going to be very dangerous or unsafe to the scientists who are doing. So we have seen so many incidents which are going to cause life because of these experiments, or we have seen the Kalpana Chawla's death because of this re-entry of the vehicle. So where the high temperature gas entered into the vehicle and they have collapsed the total vehicle. So these are some of the drawbacks we have in the experimental procedures, so that we are going for the CFD as a research tool. So together with experiments, so we are going to validate the CFD results. So without validation, the CFD cannot be considered as authenticated, because we are going to develop some programs, we are going to use some numerical methods to solve these equations. So always it is preferred to have the validation of the CFD results with experiments or with analytical results, so that we can validate our results for further experiments. Okay, so you have done for the basic benchmark validation at 0 degrees angle of attack or at 10 meters per second. So that model validation, we can do it for the 20 meters per second or 30 meters per second. So that is going to ensure us the results provided by the CFD are going to be corrected. So these are the major points why we are going to consider the CFD as a research tool. So some examples where we are going to consider the CFD as a research tool in the DNS of the turbulent channel flow or the LES large eddy simulation of the shock wave interactions. So where we have to find out the separations and the instabilities, and also the combustion of the supersonic flow combustion. So where the ignition is going to be a problem, or continuous combustion is going to be a problem, or the flame stabilization. We are going to use the different techniques so that the continuous supersonic combustion can take place to achieve the hypersonic speeds. So, and also the multi-phase CFD. So where the droplet breakup and spray for the fuel injection, which leads to the continuous combustion in the propulsion systems. So all these problems, we are going to use the CFD as a research tool. So apart from the commercial softwares like ANSYS, COMSOL, or the different softwares, we have also research organization are going to develop their own inbuilt software programs to solve these type of problems, especially as per the particular research problem they are going to solve. So which may not be available in the commercial softwares. So like plasma ionized gas flows in space propulsion. So all these exploring the microgravity, and in nowadays we are also going to see the additive manufacturing also in can be solved by using the CFD. So there is more scope in this particular domain, in this particular tool, which is going to be considered as a research tool. So ongoing research yields softwares that improves the accuracy and speed of complex simulation scenarios such as transonic or turbulent flows. So initial validation of such software is typically performed using experimental apparatus such as wind tunnels. So many research organizations or the universities are going to develop their inbuilt code to solve certain problems which are not solved by the commercially developed softwares. So even that programs or the codes are also to be validated with respect to the experimental apparatus results. So final validation is often performed using the full scale testing such as flight test. So thus we are going to consider CFD as a transportable wind tunnel also. So comparison to the experimental apparatus. So in terms of apparatus, the experiments requires the large scale testing facilities, as already we have discussed, and they require the shock tunnels or expansion tubes. So where the apparatus changes from experiment to experiment. So we cannot solve all type of problems with a single apparatus. So we have to change the apparatus according to the problem which we are going to face, and also the equipment like Schillerian apparatus we are going to use, or shadowgraph method we are going to use, or the cameras which we are going to use have to be changed. So like that, each and every equipment or apparatus changes from experiment to experiment. Because of that, the cost of the research in the experimental procedure is going to be very high. So if you are going to consider the CFD, so just if we are going to have the high performance computing with a number of process clusters, powerful workstations, they can solve any type of problem with the software which we are going to use. So only these softwares we are going to install, or we are going to change the software parameters, or we are going to use some user defined functions as per the problem. So, but this is not going to have much cost on the apparatus requirement. So once you have developed your code, okay, like OpenFOAM, SU2, so these are all the open source programs. Okay, so if you consider the ANSYS, Fluent, Star, CMM, COMSOL, so these are all the commercially developed software where you have to pay to the company to include certain equations or to include certain commands to solve the particular problems. Whereas OpenFOAM, you can develop your program, you can reframe the program as per your problem which you are going to solve. So that the CFD has the advantage when compared to the experimental procedures. Similarly, the time which is taken for these experiments. So generally we are going with the physical models that are being developed and we are going to test. So that model fabrication will also takes a lot of time, and depending upon the material availability and depending upon the instrumentation, it may goes up to months also. So even though the running of the experiment is in milliseconds, okay, but the time taken to fabricate the models or to change the model dimensions to conduct the experiments so that the final output is obtained. So it may take up to weeks and months, and data reduction or analysis also. So whereas in CFD, we are going to set up the geometry in the CAD software and we are going to change the geometries. And the simulation time depends upon the turbulence models which you are going to use. If you are using RANS, it may take in hours or days. LDS may be weeks or DNS may be months. So that's the time variation we are going to obtain. So as said, the cost of the experiments is going to increase based upon the number of models you are going to create. So based upon the testings you are going to do, whereas the CFD is going to give us the results with a low cost when compared to the experimental process. The experimental requires the maintenance, so the repairs, everything. So whereas the CFD maintenance is very low compared to that of experiments where you have to do the routine maintenance to the computers. And the limitations. So in the experiments, we have the shortest test times. So as said, when we going for the hypersonic speeds, it takes in milliseconds or microseconds. So measuring all the conditions, measuring all the results, so within the less time is one of the limitation in the experimental procedures. So whereas in the CFD, we are going to extract the data and we are going to analyze the data so that we can have the enough time to get the results more accurately. So the advantages of the experiments is provides real physics. So the data under actual flow conditions can be obtained with the scaled models. That is one of the limitation. So whereas the CFD can provide the full field data, either it may be velocity, pressure, temperature, density, any type of parameter. So when we are going for the experimental apparatus, we are going to use some pitot tube or we are going to use some sensors for different flow parameter like pressure sensor, temperature sensor. So each sensor will be used differently to provide the different data. So that is the one drawback in experimental processes. So with these drawbacks, we are going to consider CFD as a research tool. So as per my research, I have conducted this experimental CFD analysis on a hypersonic intake. So where we are going to take the hypersonic flow Mach number 5 and it is going to create a shock wave, after which the flow reduces to Mach number 4.3 and then to the Mach number 2.6 green color, and then here we are going to see some flow separation. Okay, this blue region indicates flow separation. So this problem has been analyzed by using the CFD. And next, in this case, I have used the injection method to suppress the flow separation. So here the flow which is coming from the inlet creating shock waves and the shock interacting with the boundary layer creating a separation. So that separation is separated by injecting the separate flow into the model. So this type of analysis we have done by using the CFD, so which is a research task which cannot be done easily in normal academics. So next, coming to the CFD as a design tool. So we are using the CFD as a design tool in industries. The industries mostly they are going to have the final product so which is going to be delivered to the customers as per their requirement. So in the final output process, so we have to evaluate the performance of the designed component. So to evaluate the performance, we are using the CFD as a tool, and we are going to compare the results, and we are going to analyze the performance of the final product both qualitatively and quantitatively. So if the final product has any certain drawbacks in the performance, so then and there we can understand the factors which are affecting the drawback, and we can do the design modifications. So we can change the design with respect to the output which we have attained in the CFD, and we can make the final output more efficient way. So here in this diagram, the flow over and a car is racing car is shown. So where majorly we are concentrating on this flap, where it is going to reduce the flow separation or the wake regions, so that the drag can be reduced and it can move for the higher speeds and the fuel consumption can be reduced. So similarly, we are going to consider the CFD as a design tool because of certain reasons. So one is the virtual prototyping. So as we have seen in the research tool also, so to understand the behavior of the components, to understand the behavior of the design, the in the design process we have the preliminary design and the detailed design and the conceptual design. So in each phase, we are going to make some design with respect to the analytical studies or with respect to the history data as per the speed of the aircraft. For example, we want to design an aircraft for a fighter aircraft which is traveling at Mach number 2. So for the design of fighter aircraft, we need the swept back wings. So we have considered initial design with respect to the analytical studies. So if that design is not satisfying the requirements, then you are going to increase the sweep angle. And if it is not satisfied, then again you are going for the highly swept back wings, or if required, we can go for the variable swept wings or the delta wings. So this is the virtual prototyping. We are not going to fabricate the models, and we are not going for any type of design manufacturing process to develop that model. So virtually we are changing the design parameters within the CAD software, and then we are going to solve that problem in the CFD. So this saves the time and money in industries, so that they can give the maximum output and the production cycle can be increased. So similarly, the performance prediction. So CFD predicts the aerodynamic forces, pressure distribution, heat transfer, lift, drag, thrust efficiency. So all these parameters can be obtained by using the CFD. So according to the component, so if it is a wing, we have to calculate the aerodynamic forces. So if it is a nozzle, we have to calculate the thrust. Okay. So as per the component, we can understand the performance of the product or the tested model by using the CFD. So designers use these predictions to decide whether the design meeting the performance targets or not. So if it is not meeting, then again we have to change the design. So that is one of the advantage of the CFD as a design tool. So optimization of the designs. So optimization plays a vital role when you are going to have the multiple design parameters. So if it is a normal beam, or if it is a normal convergent duct or a pipe, so where the diameter is going to play a vital role in analyzing the flow parameters. So if you are considering a wing, so the wing has the so many design parameters like aerofoil shape, or the sweep angle, or the chord length, or we can consider the span, okay, or the twist area, or the sweep angle. So all these design parameters has to be optimized to get the solution for the wing, because every parameter will affect the aerodynamically. Okay, if you are going to change the sweep angle, it may increase the wave drag. If you are going to change the length of the wing, span of the wing, it may affect the structurally, or it may increase the induced drag. So like that, each and every design parameter will affect one or in another way, so that the total aerodynamic efficiency will changes. So we are going to use some of the optimization methods like surrogate based method or joint methods in the CFD, so that the CFD itself will changes the design parameters in its solver, and so that the final optimized output can be obtained by using the CFD. So with respect to that, we will be having the like adaptive grid methods, or we are going to have some of the methods where the CFD will suggest some of the changes in the design, so that the optimized design is going to be obtained without going further changes in the CAD softwares. So similarly, integrating the engineering workflow. So this is one of the best or most important performance of the CFD. So where it is going to integrate the CAD or CAE tools, so that the changes in the geometry can be simulated instantly. So when you are going to test any model in the experiment, we are going to do the aerodynamic analysis by using the wind tunnels. Similarly, we are going to test the structural ability of the materials by using the UTM or any other materials, another testing apparatus. So here we have to test the model by placing it in the different apparatus, and we have to correlate the results, and then we have to come for the final conclusions. So that is very complex task and a time consuming task. So in the CFD, we are going to integrate the tools and we are going to get the solution. Like if you have a FSI problem, fluid structure interaction problem. So once the flow has been solved on the body, so then with respect to that pressures attained, then it is going for the structural analysis. So this type of integration is possible easily in the CFD, so that the solution can be obtained with multidisciplinary design optimization. So that we can proudly, or we can confidently say that the particular design is safe in different operating conditions, okay, with respect to the pressure loads or with respect to the thermal loads that are being attained on the components. So this is the one of the advantage why we are going to consider the CFD as a design. So similarly, so CFD is going to reduce the experimental burden, the wind tunnel testing or the flight testing, so which is very, very expensive. So the number of required experiments can be reduced with respect to the tools which we have, and we can have the final validation of the prototypes. So, and similarly, the CFD can use the real operating conditions, as it may be variation in the altitude or variation in the speed, variation in the angle of attack, or any type of real flow operating conditions can be simulated by using the CFD. So, but when you are going for an experimental procedures, as they are going to be done at the ground level at atmospheric conditions, so either we have to change the operating medium. So instead of air, you have to go for the low density gases, so that can simulate the high altitude conditions. So again, this requires a special apparatus to store that gases and simulate that one. So that is going to have one more complex problem in doing the real flow conditions in the experimental procedures. So whereas in the CFD, you are going to change the gas conditions and you are going to give the results in a more accurate way. So that is the advantage of CFD as a design tool. So these are the major points why we are going to consider the CFD as a research tool, as a design tool. So at summary, we can say the CFD as a research tool. So we can discover the things which are not easily captured by the experimental procedures. And also CFD as a design tool, we can decide whether the final product output will use the solutions or not, the best solutions or not. So CFD as a research tool, so its fidelity we can consider it is very high. because of using the DNS and the LES and the detailed models, or we can have the more developed models as per the problems. Okay, so whereas in the design tool, we use the moderate models, RANS models, to get the solutions more accurately. So the time scale which we have taken for the research tool is weeks to months, or it depends upon the problem. So whereas for the design tool, it can obtain within the hours or days. So the output of the research tool will be new models or new turbulence models we can develop, or the how to analyze the new data sets we can obtain. And using the CFD as a design tool, we can optimize the designs and we can predict the performance at off design conditions. So generally the CFD will be used by scientists or academics as a research tool. So whereas for design tool, mostly it is used by engineers or the industry people. So we can make the rigorous validation for the research tool, and we can make the spot validation, and we can ensure the safety margins. So thus CFD is a research tool when the aim is to gain knowledge of the physics flow problems that are being come across in the day-to-day life. And the CFD is considered as a design tool when the aim is to apply the knowledge and develop the new products to optimize the performance of the existing products. So that I'm going to conclude today's lecture, where we have discussed about the CFD as a research tool and design tool. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.